I'm super stoked to be here once again. I'm happy that the PyCon organizer team still invites me, even though I don't speak about Python at Python conferences. So yesterday, the first day of this conference, Twitter reminded me that yesterday was my 10-year Twitter anniversary, which also means I've been using Python for 10 years as well. Shit. Okay. So I have a day job. I work at ESM1. We build analytics for esports and tooling. So, and when I started there, we had to build a project using Python, and then we installed a developer environment and set up Python 2.7. And then I looked at the calendar, and I realized that Python 2.7 end of life is in a couple of years. So then what the hell is switch to Python 3? So now I'm a happy Python 3 user. And later on, I realized that PyCharm has support for mypy out of the box. So now we do functional programming in Python with types, so which is pretty neat. But here's the boring part. Sometimes when you don't do any cool job like writing system programming tools or doing data science, you have to do something boring, which is web apps, which is probably which most of us started doing for money when we started using Python. And building web apps entails doing lots of forms and validation. Like you have to do this on the client and on the server, and this is pretty boring, and you would like to have a single unified tool that does this for you. And back then I started with Django 0.96, which was a great tool. I started using immediately because the it work page was so great that I thought that if I start using this web framework, all my web pages will look just as great as this one. Obviously, I was wrong, but what still impressed me about Django is that you had this DSL for defining models that translated your code into SQL queries and SQL create table statements, which let you do Django admin when you could do create, read, update, and delete with just a tiny number of buttons. But it didn't really cut for me, so in Django you have this thing that you have to build templates of HTML and then add strings which generate more HTML inside, which was the Django templating language. And there you had to embed stuff like URLs, and if you were young and naive like me, you were just hard-code URLs right into the template, but then you realized that Django URL routing has a reverse resolution process that lets you use a name of a view as a string, and then Django will look it up and put the right URL for you. But still, if you make a typo, you will find out that the link that you put in doesn't work at runtime. And over time, I don't want to make stupid mistakes like that. I would like to work on my web application as is, right? And the earlier I have type errors is the better, because errors beforehand save me really long and gruesome testing time, so I want to avoid that. I want to have types out of the box. Like I ended up using a library called Servant, which is the Haskell library that lets you define the structure of your REST API as a type. And then the type system guides you how to build an implementation for every handler, right? But you also have to think about stuff like client-side applications, right? Because pretty much every website is something that does dynamically on your web page, and you end up writing code that marshals your stuff in and out of the browser to your backend server, and this actually you end up doing a lot of work. You have to define type definitions to make your deserialization fast, because it relies a lot on type information for performance. And you want to avoid writing that code altogether, because this has nothing to do with what your application is supposed to be doing, right? So this is a typical example of using Google Protobuf for client-side, and you have to do stuff like compile their internal language to JavaScript, and then construct objects, and then deconstruct them when you read them off the wire, and this is pretty boring, right? If you're too bored with well, JavaScript, you can use any other language for front-end that you like. Like a lot of people are using Elm because it has great error messages, but you still have to think about communicating with a backend, and you have to write stuff that converts the type representation from your backend server to the client server. So for example, here, the developer of this library is using GHC generics with an extension to Haskell compiler to spit out syntax for Elm. So he can then use REST or whatever HTTP APIs to get this data out of the server, right? And this is my favorite example of what you often end up doing in your Django applications when you want to have real-time communication. You have to use WebSockets, and you end up using Django channels. But you still have to write this code that connects to a proper URL endpoint, sets up a WebSocket connection, and then set up a bunch of callbacks that read data in and out. Like, you end up doing this. Like, you basically end up doing plumbing for your web page. And this is stuff you pretty much hate doing in a web app, right? You have to think about moving data back and forth. You have to think about URLs and naming. You have to think about how your API is structured. But actually, your business logic, what your app makes money from or how it's useful, has nothing to do with all those three things, right? So I'm a regular at PyCon, so I decided to check the agenda for all past conferences in this one, so I've constructed a pie chart. So a big pie slice of the topics at every PyCon is about parsing JSON, or how slow it is to parse JSON, so we're going to use protocol buffers, or we're going to use message pack, or something like that, right? But that doesn't cut it, because Python has major releases every year or so, so another big slice of the talks are about async I/O. So we end up parsing JSON and trying not to block our event loop because we're doing CPU-intensive tasks, right? So yeah, the rest of the parts of the talks is about using JSON and marshalling data with async I/O, which is really a trend for the last two conferences here, right? But there are also long-time Python users, so they end up discussing Django and how to run in Python 2.7, and the quirks are doing that, right? But for another 2 years, there's been another trend. There's a huge company called DataRobot that's doing data science, and there are a lot of people that are doing data engineering, so a lot of talks are dedicated to doing data science with Docker, right? And there's this one guy who talks nonsense all the time about languages that are not related to Python, so but I have some ideas that I would like to steal from those stuff to apply to Python development and web apps and stuff like that. So I was thinking how to avoid all those boring stuff with serialization APIs and URLs, so I wanted to try something else. A friend of mine is an author of a library for Erlang that's called N2O, which is a fork of Nitrogen, which is a web framework, basically. But one of its main points is that pretty much everything in Erlang is a process, and Erlang doesn't have async I/O because it's async by default. It does counts instructions that your bytecode interpreter runs and does preemptive scheduling, which avoids all kinds of problems that you have had 10 years ago in Node.js, and now you have it in Python 3.6. Well, okay, Node.js is younger than 10 years, so probably 5 or 7, right? Okay, so pretty much everything in Erlang is process-like, so your web page is another process, and you just send messages to it, and it magically appears on your front end because it's also a process, and everything is records. So you use internal Erlang syntax to define the layout of a web page. And if you don't want to do that, there was a 100% compatible library for Erlang that's called earlydtl that supported Django templates. So earlydtl was a gateway drug to move your development from Python to Erlang. Right, but recent releases of N2O still need you to write JavaScript code, and I don't want to do that because, well, this is a Python conference, and I hate JavaScript, like most of you guys do, right? So you still need to have a front-end hacker on your staff so they can build these apps. Now I want to give a shout-out to Pyjamas. Does anybody remember this library? There's a website called pyjs.org. Yeah, there are 2 geeks who remember that, right? So there was this thing called Google Web Toolkit that lets you do Java and then spits out JavaScript so you can do like self-real-time web apps or whatever. And I was using it when I was in my last year of high school to build an interactive real-time graph that was updating live. And it was super slow in Firefox version 2, and then there was the first build of Chromium for OpenBSD, which was ruthlessly fast. So Pyjamas let you write Python that was then compiled to JavaScript. Obviously, it didn't support all of the language features that Python had, but it was a pretty good thing, right? But still using a tool like Pyjamas is not an option for me because I don't want to end up all these things like marshalling data in and out, because lots of tools that are marketing themselves as different languages that substitute JavaScript for you on the front end, they still have this problem. You still have to do some kind of communication with your backend, right? So Python in the browser is not an option. Elm and PureScript and Fable, which is the F# compiler for JavaScript, it doesn't work. So you have to be really isomorphic, right? So I've ended up looking, and I found this tool called Meteor.js. Nobody knew about it 5 years ago. Then they raised some funding, so they're all over the place right now. And they seem to build impressive web apps. But I didn't want to do JavaScript, right? Then I found a tool called Your Web, and I started using it, which is what my story is about. But there's also another tool called Oxygen, which is a set of tools for OCaml, which is a functional programming language that's based on ML. But when I remembered Your Web, I forgot about Oxygen, but then I realized this is not the tool for my job. Anyway, so I've ended up picking the most popular project on the internet that has only 492 stars. It's 8 years old. It's been developed by one professor of computer science that does certified. He wrote a book about certified programming with dependent types. So he's pretty much into software verification. So this tool must be really nerdy. So I've ended up using it. Its compiler is written in standard ML. And now I'm going to talk to you about the language. If you go to the website, you can check out the tutorial. It's pretty simple. And the thing I like about UR is that it's a dialect of standard ML, which is one of the very great languages that's used for teaching computer science in the US. And a lot of cool courses, online courses and algorithms are taught using standard ML. And it has a lot of pretty advanced type-level features that you can use to make your code to express more invariance about your program and your code. But there's a spoiler. I mentioned that I could use some ideas to transfer them to mypy. Well, you cannot, because mypy is pretty, it's a pretty basic tool which still yields a lot of good effects on your programming workflow in Python. Anyway, so it has a lot of features, and I'm going to go over them one by one. I'm going to skip some of those, but what's really important is that UR is one of the languages that actually has a formal specification of how you define valid terms. So if you open the manual, you can find all of the typing judgments for every term in UR, which means if you build a compiler, you can actually check it against the spec and do it, which is not the case for a lot of common programming languages like C or even Python, which doesn't have a formal spec, right? So the language looks pretty cool, except the only thing is that it has types and it has type inference in it, but if you use a lot of polymorphic tools, you end up hitting undecidable type inference. So if you don't add type annotations all over the place in your polymorphic code, you're going to have a bad time. So this is how the map function looks like, and you cannot call it map because map is a keyword. So this is like standard ML. Well, I wanted to say just ML, but standard ML is also in language, so there you go. You can do loops and tail recursion, all the stuff that you would expect in any functional programming language. You have data types, and you can run polymorphic functions over data types with a type parameter in it. But what's really cool about this family of functional programming languages is that it has a feature called modules. So a module, which is pretty much what you would expect from any other language, which is like a .py file is a module, but what you have here in ML is that you have module signatures, which means header files are the new black again. So you can define your module signature and have multiple modules implement the same thing, but what's cool is that you can parameterize another module with your signature, so you can build a module on top of a module, which is called a functor in ML. It's pretty cool. In this case, I was using it to build a backend that would use OAuth to authorize your users through GitHub. And what you have to do is that you define one module signature, you implement a module that has the signature, and you use it as a set of arguments to another module, which is really a feature that's lacking from a lot of programming languages. Like in Python, if you want to have some kind of parametricity, you have to use classes, but classes, like from an implementation standpoint, don't really have a lot of differences from the module itself. Another cool thing is it has row types, so you can think of that as like dicts on steroids. Basically, the type system tracks addition and removal of keys from your dicts by default, and which lets users implement really complex features like SQL query parsing and SQL injection prevention and all sorts like that. It also has higher order types with special behavior, like what you used to think of monads in Haskell. Basically, you can have a computation that can terminate at any point in time. Basically, you can have a type that has an error function defined. So there's a separation between pure functions and impure functions. Like in Python, your default way of doing error handling is raising exceptions, which is a really cheap thing to do in Python, but you cannot tell a function if it's raising an exception or not, and even mypy doesn't support exception tracing, well, annotating and tracking exceptions, like nym does, for example. So this is a bad thing. And here you have a special type called transaction that lets you call error. Okay. So now I'm going to talk about the really cool part that's going to freak people out, the web framework, right? So every time you start evaluating a web framework, you have to end up writing some kind of a benchmark tool for doing web stuff. Like if you're testing a front-end page, you're doing to-do MVC, which is basically a list of to-dos that you can add and remove, which showcases how much memory your browser is using to keep track of a shit ton of objects and stuff like that. But my friend Max, who wrote N2O, he came up with another benchmark for web frameworks, which is how do you implement a chat. And a chat has to do some reactive stuff like sending data on and off the page, do persistence and stuff like that. So he came up with the idea of using a chat, and I've built an app that's a chat where you can reenact Data Robot's War Room, for example, right? Okay, so I have the code for this online on my GitHub, so you can go check it out. It's a URC, which is a pun for IRC. And what's cool about the language is that transaction is the type that, well, actually, your web's compiler figures out which code has to run on the server and which code has to run on the client. So you never have to think about that in like 94% of the cases. So right here, you have stuff mixed like defining variables and writing XML. So XML is also an internal feature of the language. There's a step that desugars your XML into properly typed code and then spits out actual HTML. So I'm going to showcase this a little later. And another feature that's really important is that you have all those primitives that you would like to see from a web tool that lets you do server-side pushing and functional reactive programming tools like signals and sources, which is a part of this framework as well. And there's a notion of RPC, so there are sorts of functions that you cannot call in the client, like something that writes to a database. You have to rub into RPC, and there's just a simple function call and all of the argument marshalling is done for you, so you don't have to do any extra stuff to figure out which is the URL, which is the post, which is the get, and stuff like that. To review, most of the internal details of HTTP are hidden from you when you're developing an app in this language. So you don't have a way to tell your application if you would like to make a post call or a get call because the compiler figures it all out for you. There's no notion of URLs, so it's a really hard way, well, figuring out which URL your function is being handled by is a really hard thing. And you don't really want to think about that because it's, well, an implementation detail. You just want to do like forms and navigation and stuff like that. Finally, there's no way to set an HTTP status code, so it can be either OK or internal server error, which is pretty cool because, well, who does remember what kind of error codes you have to send at what time? And the runtime of this language actually handles some of those like for you by default. Like it knows where it has to send a 301 or 302. It knows when to send a 404, obviously, but that's pretty much it. If you're a user of the library, you cannot set any error code, and this is great, right? So all the things that I've mentioned already, RPC, server-side push, and client-side push for using FRP. And the only way you can do stuff like access HTTP deals is to set cookies. So you want to have some client-side state, like remember the authentication token, which is pretty much the only use case I've needed so far to know who your user is. And you can read and write headers, which is like you use it like never. So that's pretty much it. And looking at that, you might think, well, I don't want to do this, right? I want to be in control of what my web framework does so I can write applications in the exact way that I want. But hey, I mean, relax. The only way of getting what you want from a tool, which is the productivity boost that you need to write the application that you want, is to give up on all the details and just roll with it, right? Because if you're looking for the tool that you like, at first you try to coerce it to do the thing that you're used to be doing, but then you realize that the tool that you've just taken isn't about the feature that you need. And you just forget about it and just roll with it and get a pretty good productivity boost. Yeah. So now I want to talk about Sugar, because Your is a language that's all about syntax sugar for your apps. So for example, it has a syntax for tables, which is the only way you can do global variables in this web framework. You cannot do any sorts of persistence without going through a database. You cannot read any state information without going through a database, and Your supports PostgreSQL, MySQL, SQLite, and something else out of the box. So anything that looks like SQL is transactional by default, and it's supported out of the box, and it's part of your syntax. Okay, but when I'm talking about Sugar, there should be a way of debugging it. When, for example, you're using Python, and you can understand how the library works because you're seeing strange runtime errors, and you go through the documentation, and you find nothing, you start reading the code, and instead of reading the code, which you can do in Your, you can see how the compiler transforms the syntax Sugar into something else and figure out what the error is in terms of simple expressions, right? So Your Web's compiler has an option called timing that lists all of the compiler optimization passes that your code goes through at every point in time. And those optimization passes are pretty well documented. And what you can do is you can tell the compiler to stop after any optimization pass and show you the pre-printed intermediate representation of the code that's being spit out. This is something you would like to see, for example, when you're doing like meta-programming with Django databases, like stuff like that, when you cannot see the intermediate representation. And if you're just using the compiler, this is the thing that it does by default. So one of the downsides is the error messages are ugly, so you don't have to look at that. Okay. Here's how basically embedding HTML looks like in Your, and it's really hard to mess up writing improper class names in your XML code because all of the styles that you're using in your application have to be explicitly defined in code base, so you don't do any typos. And this even works even if you put style names into quotes, so the compiler won't let you screw up like that. And this is how this code looks. It pretty much translates into well-typed terms of Your, so you don't have to write them by hand. So you can just write XML, and they transform to regular terms. And you can do any term-like manipulation that you're used to be doing in your own pure functions. The same thing happens to SQL. And if you stop your compiler with an option that's called elaborate, you can basically see that this is what your SQL code transforms to. So this is pretty cool. Another good point I have to mention is that the thing that makes it really hard to write custom HTML code in Your actually makes you good friends with the CSS guys in your team. Because basically, Your removes your desire to do hard code like style information into HTML, which makes you do it in CSS, which is okay, which really makes you good friends with your CSS guys and front ends, and then you realize how powerful CSS is nowadays, and you stop doing shitty HTML for style. Okay. And this is what table converts to. So another thing I want to showcase is metaprogramming, which is a feature that most of you expect in any decent programming language, and I'm surprised that I've seen a talk about NIM this morning, and I'm surprised that NIM still generates AST. So this is the stuff that you don't want to do, is that because your macro system doesn't let you, well, it lets you define the code that won't type check later. So you basically end up pushing the responsibility of debugging your ill-constructed code to a later compilation phase, and you won't get error feedback early. So that's what you don't want to do. And that's what happens when people are generating code using an AST library in Python. this is you don't want to do as well. And you definitely don't want to be doing stuff like using Django meta classes to construct values out of values in runtime. This is what you end up doing with Java reflection and all sorts of things like that. The earlier you do your transformation on your code and generate code out of code, the better, which is available with type-safe functors in your, and is available with stuff like metaprogramming on types. So basically you can run a function that converts a type into a type and lets you do all sorts of cool things like polymorphism, constraint polymorphism, and so on. So I've used the feature of type-safe functors to build a Django admin, which here is called a CRUD module. So here I'm using I'm using functor and instantiating with another module that's called, well, it's called here a struct. So what I end up doing is that I pass it the name of the table I'm using. With a hash logging, I'm saying this is the primary key that my table is using. I'm giving some options how to represent my data in the table, and that's how I get a Django admin-like functionality where I can just click, delete, and update and stuff like that. So I'm just writing my type definition, and I get UI for that for free. And what's cool is that I can also add any stateful checks that I need to my code by just, say, using the header function. For example, I don't want to have my users access my app unauthorized, so I just add a necessary check to a function, and that's it. It calls error inside if there's no user, so that's it. OK. So another thing is that your makes you write C code. So by default, your lacks pretty much any stuff you would expect from a programming language with effects. Like, it took me like a week to find a function that lets you generate random numbers and see current time. But what it actually also lacks is an ability to call another web server so you can like do a get or post query. So this is what you end up doing if you have a microservices architecture. So to do stuff like that, you have to write your own functions that look like regular your functions in the code, but they're actually using FFI. So hey, go back to C, and we can end up using curl. This library is called World. It's in the on the official GitHub organization repo set, and I've taken some stuff out of it that I don't need, and you can find it on my GitHub as well. So this is how you end up exporting that stuff. So you just export two functions that end up doing curl inside. The FFI is also available for JavaScript. I've seen people that are doing WebRTC in your. It's really slick. It looks pretty cool. You have to basically end up hiding all the JavaScript API crap into a tiny FFI library and then just doing all the session management signaling and stuff like that for your WebRTC real-time app in your. OK. Now I'm going to talk about packaging and deployment. So this is a cool thing. The cool thing is that UR has been developed pretty much by one person, and that means it's really hard to find commercially successful software that's using UR, and I've found only one. That's called a company is called bestcox.com, which is a clone of Google Reader, and it's a pretty impressive application that's also been developed by another person. And this is the only commercial app that I know. But it means that as long as the language ecosystem has a small community, nobody invents their own package manager for this language, right? So you can just reuse someone else's package management tools and be happy with it. So some things you need to know about using this language is that the compiler of your, in the end, generates just plain C code that it links with your runtime, and it outputs a single binary, which ends up using a little amount of space in memory. So actually, if you run bash and see how much memory bash uses, it's still more than what would your web app do if it just started up, which is pretty cool. There's little support for doing stupid I/O, like reading configuration files on every request, because it encourages you to compile all of the application configuration information to the binary, but you can still do stuff like do SQL transactions in every in every view that lets you read applications. So to package it, I'm just using the Nix package manager. And if you don't know anything about Nix, you just have to remember when you go out that Nix is just better than Docker. And, and pretty much because if to write Docker specs, you have to write things like Docker files, which are shitty DSLs for stack-like DSLs for Bash. Nix is a programming language that lets you do lambda calculus on top of Bash, which lets you write really complex composable build steps, and it lets you harness all sorts of languages in one configuration file. Like, for example, you can build Python apps alongside with their C dependencies alongside with your web apps in one pass. So this is how the definition of it looks like. Basically, I'm using Nix to take advantage that curl is using automake to build, and I'm saying that my thing depends on curl, and when your web links my library, it ends up knowing where all the linker configuration has to be, and it just gives me a library that's already linked to curl, then I can pass further and just link with my application. There's little to no work to be done to do package management and dependencies with Nix and your. Okay. So something that you need to be aware of is that when you're using you cannot really Google every problem on Stack Overflow, right? So this is what happens when you end up using a technology that's not that popular. So there it is. So there's only one 70-page document that's called the Your Web Manual. It pretty much covers every concept that your web has to offer, and you have to read it if you end up using it, which is pretty much the case for every kind of tool that doesn't have wide adoption, but it solves the thing it has to do pretty well. So you have to read the documentation and know that if the author of this tool is a professor of computer science, you really have one good question to ask to him, because if you end up writing him an email and say with a stupid question, he's not going to talk to you anymore. So you really have to choose your own battles when trying to use a tool that's that unpopular. Okay, so there's a lot of demos on the website that's called just a list of demos. Pretty much it has pretty much every feature showcased, but when I work with Yori, I basically end up with the source of your web available right next to me. I've never looked into the compiler source because it's pretty okay, but I still end up looking into runtime code, which is in C. So now I have to say something about productivity. So I've only written 2 apps in Yor by now, and the reason I'm doing that is that I pretty much can prototype all of this stuff alone, which is a really important thing before you pass some tool that you need to another team of hackers that end up implementing fancy HTML pages and doing fancy backends with super fast storages that are custom built, that are doing peer-to-peer file synchronization or what have you. So basically, the learning curve is slightly steep because you have to debug the type checker to understand error messages because they're pretty much filled with types at every point. So you have to be extra careful and actually read what your terminal says to you and not just assume that the problem is in this. And you still end up doing binary search to debug, so you basically comment all of the code, make sure it compiles and uncomment the first half, and then you just keep drilling down until the code that you're using starts compiling. So there's a slight learning curve that I've estimated to take 2 evenings of your time, so you can be productive with this tool. But if you actually overcome this problem, you're going to be pretty happy that it lets you do prototypes, get them out pretty fast, and get them deployed in no time. So that's pretty much it. I want to say that we have a meetup that's called KievFprog. We're doing them not so regularly, but this is where we discuss stuff like this in detail, and there's a big vibrant community going out there, and I'm really happy that PyCon welcomes it. So that's it from me. I'm ready to take questions, and let's party. Thank you.
Thank you.
Hi. So what is the answer to the question, what to expect from?
Well, I would just expect that it won't give you as many advanced type-level features that you probably might want to use if you hang up on any of the functional programming languages. But I really expect people to start using it by default.
Okay.
So, by the way, who's using mypy in your code base? And out of those like 6 people who raised their hands, are you using PyCharm? Okay, there are like 2 people, 3 people. Interesting. But here's a pitch. It supports out of the box, and it really gives you a nice productivity boost if you start writing type annotations. This is actually an interesting point, because a dynamic language like Python, it lets you do escape hatches to do dynamic dispatch all over the place whenever you want, and people end up not using any of the type annotations because they just get in their ways. So what I would say is that the faster you switch to a type programming language, the better.
I have a question.
Okay, go
like,
ahead.
is transaction type, is it like Haskell IO monad?
Yeah, I actually had an equality sign right next to it. It's really similar. So yeah, it does tracking for when you want to commit a roll vector transaction out of the box. It knows which code is supposed to be run on the client and which is run on the server. So yeah, and you can call error at any time. So yeah, that's pretty similar. It's also a type. It's also higher order type. It has these things called return and bind. So it does implement a monad. I don't think anybody checked the monad laws, but the interface is really similar.
One question for me.
Right.
You are talking about some crazy things, each PyCon. How many of them do you use in production?
Every single thing, yeah.
Cool.
So yeah, I've been using Haskell alongside Python for years now. We're starting to use your web. There are like 1.5 people that are using it full time right now, because that's the thing. And yeah, we're using Nix, so pretty much everything. Yeah, it coexists pretty well with every Python stuff that you end up using. And the truth is, you always go to PyCon because there's always a library in Python that gets you where you need to go. And there's no way you'll stop using Python. So this is like the community of people that are stuck with it.
Hi, thank you for the talk. And what is the time to market like in comparison with, for example, Django?
Well, the thing is, right now, I've just written 2 apps. Is that the time to market is that usually you do a demo after you build a prototype using Your, and then you start rewriting, say, in PHP. That's a sad story that I'm going to tell you today. But basically, it lets you get the prototype out fast in like 2 evenings, which is the case for this tool. It performs really well because you don't have to spend time thinking about like table layouts, like backend chat, like APIs, URLs, and anything like that.
Can I create SPA isomorphic application using this technology?
Yeah, so here's the tackle din. It accepts signals, which means if you write into this variable called res, you end up live updating the web page. So there you go. It's an isomorphic technology for doing SPAs. Yeah. And it's so boring and easy to use that I couldn't even get into detail talking about it, which is pretty impressive. Yeah. But you still have to be careful because, like, well, the model here is that you end up writing a function for everything, and just a function accepts arguments, and the compiler takes care of all data marshalling for you. And it's pretty easy to stop doing SPAs and start just doing page navigation because it's so fast. You end up writing, doing form submissions that load a new page just because it's so simple that you forget about SPAs, and that's it.
Okay, how about integration with a huge amount of libraries in npm from JavaScript world?
Well, there's JavaScript FFI, and if you want to do, you'll end up doing npm install if you're using something crazy, right? But there's an FFI that people are using to do stuff like WebRTC and integrate leaflet and stuff like that. So that's available on the internet. But I'm also using FFI for, writing shit to blockchain and stuff.
Okay, thank you, Vova.
All right, thank you guys. Have a good time.